Thanks for your time today, Ron.
You're welcome.
You're a man who needs really no introduction of any kind. You're known in Canada as the billion-dollar man. But if you could just give me the quick 411 on who you are and what you do and what you're doing here at AIBC 2017, that would be great.
My name is Ron DePauw. I'm a retired wheat breeder with Agriculture and Agri-Food Canada, and released many varieties of wheat that have been widely adopted by producers. And the team that we worked with in the wheat program at Swift Current have really been very successful in meeting the demands of the farmers and consumer expectations. And they retired from Agriculture and Agri-Food Canada in March of 2015, and I've carried on with my love of science since then, and have started a company called Advancing Wheat Technologies. And one of my primary contracts is with SeCan Association.
You were speaking today about barrier-free innovation, and it's a very complicated concept. It's far from simple, and you have some very interesting thoughts on it, and as to whether or not it's even possible to have such a thing as barrier-free innovation. What is barrier-free innovation, and is it truly attainable?
The topic that was for the session, barrier-free innovation, I think was deliberately chosen to be provocative, because all laws and regulations come about as a response to something. And generally, in the case of the seed sector, let's say, the Canada Seeds Act was formed somewhere in the early 1900s because there was no regulations, no structure around the release of varieties in Canada. So anybody could come in and promote seeds of something, whether or not it was adapted, whether or not it had resistance, whether or not it would perform, it didn't matter, because the money was made in the selling of the seed, not in buying the grain from the farmer from that harvested product. The money was made by the person who sold the seed. And of course, they didn't have to be around to take the heat of their products that didn't perform according to their claims. So as a result of that, then the Canada Seeds Act was devised, promulgated, and the attendant regulations, and it's gone through a number of changes through that, and that governs many things in the seed sector, like the variety registration, the pedigreeing system, and so on. There's just a lot of things that govern that, and it all comes about as a response to the need for changes. And the regulatory changes that have come about in more recent years is changes to the variety registration system to make it more transparent, more predictable. And for the farmers, what they want is to be sure that there is reliable information. From the developer side, they don't want to have regulations that would inhibit entry into the marketplace, and those changes have been made. So it's always ongoing to have these changes, but the changes come about in response to a lot of things. And the Canada Seeds Act, as an example, it was first put in place as a form of consumer protection.
You used the story of Midge Tolerant wheat today in your talk, and you talked about how the discovery of Midge tolerance was a very serendipitous event when it comes to the history of innovation, seed innovation in Canada. Can you give me a little bit of your insights on that and why that story is so important to tell?
Midge is an introduced pest into North America from Europe, and it became increasingly damaging, particularly in Western Canada in the 1980s and into the 1990s. And there was really no known variety with genetic resistance in the Canadian environment to that. And so the control measures that were devised were like insecticides, which cause a lot of environmental damage. They're expensive, and they take out non-target insect pests. So that was not a very good solution. And then there was things like rotations, where you could rotate out of the crop, like grow a non-host crop to the insect midge. Or you could delay your plantings, plant late in May, early June. But with that, you get with late plantings, you have lower yields, and you run the risk of fall frosts. So it so happened that people were scientists from the Cereal Research Center in Winnipeg, like Phil Barker and Ron McKenzie. They were looking at trying to sort out, is there should we be breeding for Hessian fly resistance in wheat in Canada? Because Hessian fly comes in rather late in the season and it causes the stems to topple over. So what they had done is they brought in the Hessian fly differentials from the United States, and they're in a soft red winter wheat background. And of course, and to be able to grow out these differentials, they had to vernalize them, give them a cold treatment, baby them along, and then in the springtime, plant them out. And they did that, and they then studied the response of the Hessian fly. And of course, they had harvested grain samples. And the Hessian fly, as I said, works down at the lower parts of the plant in the leaf sheaths of the lower internodes. But they had some grain samples from these different varieties. And one of the entomologists, Phil Barker, he noticed that some of the kernels in certain varieties didn't have a nice oval elliptical shape. That the end of it, where the brush end is, it was deformed. And he thought, well, that's really unusual. That is not typical wheat kernel. Something is causing that to happen. And they got thinking about this and then some further investigations. And they grew out some of these varieties then in cages, the individual variety in a cage with midge. And lo and behold, those varieties that had these tubby, distorted kernels, the distal end being, or the brush end being distorted, were the ones that were resistant to midge. And this was like a eureka moment. My goodness, we've got genetic resistance. Well, how is it controlled? How many genes are involved? So they did a genetic study, Ron McKenzie and Phil Barker and so on. They did a genetic study, and they found that it was just a single gene. And then subsequently, the scientists at the Cereal Research Center named the gene. It was called the SM1 gene. Julian Thomas and others got it identified onto chromosome 2B, and they developed molecular markers even to this gene. So now we could breed in genetic resistance using these molecular markers, and then when you get to the end, you could do a bioassay, grow them with the caged materials. And so it was just, that trail of science that got from, yes, there was a problem. Somebody else is looking at something else, at the lower parts of the plant, but he has grain samples later on and notices a disturbed shape. That was really, I think, a fantastic eureka moment. And it's not really well known, but to me, this is one of the beauties of science. You get eureka moments. Somebody clicks on it, connects the dots, and it has big, beautiful impacts, beneficial impacts for agriculture and Canadian society, our global society. Yeah.
Well, it's great for you to be able to bring that story here to AIBC, and like you say, if it's a story that not many people know about, it's good to be able to look back to the past, because the old saying goes, how do you know where you're going if you don't know where you've been? So I think it's a good example of that. So what's again, like I mentioned earlier, Ron, you're no stranger to the Canadian ag industry. You're retired now. You're a science advisor for SeCan. What's next for you now? Where do you go from here?
Well, I'm think of myself as really enjoying science. So I look upon it as continuous learning. And I think that for me, there is more things coming forward, more knowledge than when I was a graduate student. And to me, I'm more excited now than what I was as a graduate student. And I was super excited then, but I'm even more excited now about the possibilities of bringing forward new products in new ways. And I look forward to a self-driving car.
So are you saying you're not really retired then?
When you love something, why would you step away from it?
That's a good question. Thanks so much.
You're welcome.